my name is IZZAH NORSYAFIQAH binti Abdul SHUKOR. So today I will explain the question number 1. This is the question. The question, we know that the type of indeterminate form is different. So we substitute the value of 0 into x and we will get that equal infinity minus infinity. For the step 1, we need to get the single fraction. By equating denominator, we will get that limit x approach 0, x power of 2 minus sin x divided by x power of 2 sin x. For the step 2, substitute the value of 0 into x and we will get that limit x approach 0, 0 power of 2 minus sin 0 divided by 0 power of 2 sin 0 and we will get that 0 divided by 0. Move to the step 3. From the step 2, we know that 0 divided by 0 is indeterminate. So we need to apply L'Hospital rule. From the limit x approach 0, x power of 2 minus sin x divided by x power of 2 sin x, we need to solve it using differentiate for numerator and denominator. For the step 4, we differentiate the numerator x power of 2 minus sin x and become 2x minus cos x. Differentiate of denominator x power of 2 sin x, we need to use product rule. So we let u as x power of 2, we differentiate u become 2x. V is sin x, differentiate of v become cos x. So we substitute into the formula of product rule u dv over dx plus v du over dx. So it becomes x power of 2 cos x plus 2x sin, so limit x approach 0, 2x minus cos x for numerator divided by x power of 2 cos x plus 2x sin x. For the last step, we need to replace x by 0, which is limit x approach 0, 2 times 0 minus cos 0 is negative 1. For denominator, 0 power of 2 cos 0 plus 2 times 0 sin 0, it becomes 0. So it becomes negative 1 divided by 0. So the final answer is negative infinity. This is how to solve the question number 1. Thank you.
Hi, my name is SYAZWANI and today I will explain about the solution of question 2. Question number 2. Step 1. First, we need to identify the indeterminate form. As the question asks the velocity of the object after a very long period, it is mean that we need to evaluate the limit as t time approach to infinity. As the equation written in the slide, limit t approach to infinity, Vt equal to limit t approach to infinity mg over alpha open bracket 1 minus e power of negative k over m times t close bracket. We bring the mg over alpha in front of the limit as limit t approach to infinity open bracket 1 minus 1 over exponential power of k over m times t close bracket. It is because exponential power of negative k over m times t is equal to 1 over exponential power of k over m times t. Next, to get the indeterminate form, we must have the same denominator for the equation above, as 1 is equal to 1 over 1 times with the denominator exponential power of k over m times t, we get exponential power of k over m times t minus 1 over exponential power of k over m times t. Then, we evaluate the infinity into the equation we get infinity over infinity. Step 2. Apply L'Hospital rule to evaluate the limit. After we get the indeterminate form, we can apply L'Hospital rule to evaluate the limit until the limit exists. So, limit t approach to infinity, open bracket, exponential power of k over m times t minus 1 over exponential power of k over m times t, close bracket, equal to limit t approach to infinity, derivative of exponential k over m times t minus 1 over derivative of exponential power of k over m times t. Find the derivative of numerator, we apply the exponential function rule. The differentiation is linear. We can differentiate summen separately and pull out constant factors, and we get the derivative of exponential power of k over m times t plus the derivative of minus 1. For the derivative of exponential power of k over m times t, we apply the exponential function rule. We get exponential power of k over m times t times by the derivative of k over m times t. For the derivative of negative 1, we get 0 because the derivative of a constant is equal to 0. Next, we go to k over m times the derivative of t times exponential power of k over m times t. And lastly, we get k times exponential power of k over m times t over m. Put the final answer of derivative into this limit, which is limit t approach to infinity, k exponential power of k over m times t over m over by k times exponential power of k over m times t over m, and we get 1, and the limit is exists. Can go to the step 3. Solve the equation by substituting the value of the limits exist. From the equation given, we can get the limit, which is limit t approach to infinity equal to mg over alpha, limit t approach to infinity in bracket exponential k over m times t minus 1 over exponential power of k over m times t. We use the limit as t approach to infinity because the question asks us to determine the velocity of object after a long period, and then we get mg over alpha times 1, then we get mg over alpha. The velocity of the object after a very long period is mg over alpha meter per second.
Hi, my name is Najiha, and today I'm going to discuss about the solution for assignment 1 question number 3. The question is, now for the first solution, we can use that integration of fx dx is equal to integration of ln x over sert x. It is equal to integration of ln x multiplied by 1 over sert x dx. So since this is the multiplication, so we have to use by part solution, which is integration of u dv is equal to uv minus by integration of du. So which one can we take as a u? Now, this is the tips. We have to remember the LOPAC. Since we have the ln x here, so it is come from the first, which is logarithm, and our u will be ln x, and our integration of dv is equal to integration of 1 over sert x dx. Now, here it is. U is equal to ln x, and the integration of dv is equal to integration of 1 over sert x dx. Now, back for the u, since u is equal to ln x, so the differentiation of u is equal to 1 over x, and du is equal to 1 over x dx. Now, the integration of dv is equal to integration of x to the power of negative 1 over 2 dx. So the v is equal to 2 sert x. So we have to substitute it into the by parts, which is u ln x, v 2 sert x minus by integration of vv, which is 2 sert x, multiplied by du, du is 1 over x dx. Now, from this part to the 2 sert x multiplied by 1 over x dx. 2 is a constant, so using a basic rule of integration, we can get the u out from the integration part. So here we got 2 third x ln x minus by 2 integration of third x over x dx. Now, to solve the integration third x over x, so 2 third x ln x minus by 2 third x plus c. We have to plus c since there is no limitation. So, the integration of fx dx is equal to 2 third x ln x minus by 2 times 2 is 4 third x plus c. Now, moving on to the evaluation. We have to evaluate 0 to 1 fx dx. So, the fx dx is equal to 2 third x ln x minus 4 third x plus c. So, the limitation from 0 to 1, which is we can write it as 2 third x ln x minus 4 third x from 0 to 1. We can cross out the c since there is a limitation, which is 0 to 1. And we can substitute 1 into the first solution and then minus by 0 to the second solution. So we can conclude that negative 4 minus by 0, and the answer is negative 4. Thank you.
Assalamualaikum. My name is Najiha binti ALIAS. Question number 4. Step number 1. To rewrite the integration of rho to positive infinity 1 over x squared plus 1 dx into a limit form. So this is the limit form. It should be limit b approaching positive infinity integration rho to b 1 over x squared plus 1 dx less than 1 over 1000. Step number 2. We have to perform an integration. To integrate, we have to consider the equation of integrate 1 over x squared plus 1 dx. By looking at this form, x squared plus 1, we have to use trigonometric substitution. So let x equals to tangent theta, differentiate the theta, the d theta over dx is secant squared theta. Let's alone the dx here, so it is equal to secant squared theta d theta. Let's start the integration of secant squared theta over tan squared theta plus 1 d theta. One of the trigonometric identities. Tan squared theta plus 1 is equal to secant squared theta, so we have to change this into secant squared theta, then we have to divide this equation until you get 1 d theta. Integrate, you get theta plus c. Also can be written as arctangent x plus c. So we rewrite in the limit formation. Should be limit b approaching positive infinite tangent x rho to b less than 1 over 1000. Step number 3, inserting the boundary. Put the upper boundary and lower boundary. Limit b approaching positive infinite in bracket arctangent b minus arctangent rho less than 1 over 1000. Next, we have to solve the limit. In order to solve the limit, we have to substitute infinite value into b. So it will be arctangent infinite minus arctangent of rho less than 1000 pi over 2 minus arctangent rho less than 1 over 1000. Step number 5, which is the final step, we can solve the equation. From pi over 2 minus arctangent rho less than 1000, we have to move pi over 2 to the right side, then left negative arctangent rho less than 1 over 1000 minus pi over 2. Move the negative to the right side, arctangent rho greater than pi over 2 minus 1 over 1000. Then leave the rho alone at the left side, so it will be rho greater than tangent of pi over 2 minus 1 over 1000. So the answer of rho is greater than 999.9996. So if we can round it, it will be rho is greater than 1000. So we can conclude that the largest value of rho must be greater than 1000. Thank you everyone.